Hello, Sophia, JC, Francisco Lavoy from Janmoji. How are you guys? I'm very, very sorry that this very detailed information, has gotten to you so late. I apologize for that. It's been a crazy 3 weeks, and I was hoping that I would actually have that ready for you by then. But unfortunately, we've actually had been late by about 2 weeks on most of our designs and projects. But hopefully, we can make it up, and whatever the decision is, this we hope that I personally hope that you guys can use this as a reference, even if you have already made a decision or you decide not to go with Jinmoji. We're more than happy to share the wealth and the intellectual capital, because intellectual capital is a terrible thing to waste. All right, guys. This is an aerial view of Piloto. I'm sorry, Piloto is this area here. The areas that are in gray, these are the different buildings or um, sections of Piloto. This is the lobby patio. This is the central patio that you have. This is another one that's actually here, and there's another one here. This is the next door neighbor with his internal patio, and this is the city hall, if I'm not mistaken, with the towers here. What you see here, these are obstructions. We have air conditioners. We have the cage area in the middle with and the water cistern. We have also poles with cables and so on, which we will be working on them to make sure that they don't become an obstruction for the system. This is the new big um, power generator, and which is actually not shown on this aerial view of your building, but we're making sure that it's actually part of the equation. Now, I'm going to be going into the actual design of the system. I'm going to show you the radiance map. As you can see, we have multiple maps around, or multiple buildings around yours. And the reason why we actually put these buildings here is to make sure that we can take into account any shading situation at different times of the day, different times of the year. As you can see, we're showing very clearly what your building would be like. You know what area does your building cover? The roof. You know all the different areas within the roof, and as you can see, all the different obstructions, like the air conditioners, smaller conditioners, pipes, generators, cistern, and the cage area. They're shown in black, and they have shading around. As you can see here, depending on where I put the cursor, this map is going to give me the radians for each individual section or for each individual square meter. So you can see it's actually moved the cursor here. I'm actually going from 1.788 kilowatt hours uh, per square meter per year. And the closer I get to those shaded areas, as you can see, that actually goes down. So we need to make sure that our panel systems, the solar array, does fit in areas in which can actually, be can use the most out of the energy that we will be generating or can be generated from the roof. We have three different arrays, total of 38 panels, about 12.4 kilowatts, using 325-watt panels. And we have, as you can see, we have the biggest array is in the front. It's in the southernmost part of the building, which is right next in front of the plaza. And then the other two smaller arrays, we have them in the big section on the back side and the north side of the building. Now, if I go into the three-dimensional of this particular project, it will, give me a second, it's actually coming up. It will show me a set of information that is actually very useful for you guys to understand what's the impact of the system based on the design and the positioning of the array. Um, Also, allows you to understand exactly what is, physically, what is the impact of the different buildings around you. As you can see, you have a building right behind you, which is about 6 stories or so. You have another one which is a little bit higher than yours, which is this one here, but not that high. And of course, this one, which is further to the east, which is a little bit higher. But they don't constitute any shading issue, to be honest. And the way that we know that is using our system's Analima's, I would say, not reporting, but forecast. There you go. Analimas are basically the position of the sun in relation to the position of the earth and the time of the year. As you can see, the analimas, these are the northern analimas, which actually relate to the summer solstice, and these are the southern analimas that relate to the winter solstice. As you can see, I have a month which is June 21st at 12 o'clock. That's summer solstice. If I change this to December 21st at 12 o'clock, that is winter solstice. Notice how the sun is actually, it moves east to west on a southern trajectory, whereas during the summer it does it using, through the northern part of the hemisphere. So basically, if I was to go closer to the system here, notice how the arrays are actually elevated. As you know, some of these areas are actually lower than others within the roof, especially the northern, side of the building. That's why we're actually considering a height of about 3.5 to 4 feet for the arrays. Something similar to a carport, but with the provisions of doing it in a roof. Same thing with the backside solar panels or solar arrays. Now, if I was to get back here and take a look at how the sun moves from east to west, on the summer, it's 6 o'clock in the morning. Just about 8 o'clock in the morning, we might start seeing some production. Very little shading, but 9 o'clock, we already have production going on. Again, shading from the different elements, like the towers, the buildings next door, the building in the back is negligible. Same thing in terms of the obstructions in the middle. This is the caged area. These are the air conditioners, the cistern, and so on. Notice how there's at 12 o'clock we have some shading here, and as we go into the late hours, about 4 o'clock or so, we start seeing some sort of shading. Just about 6 o'clock, look at how the shading starts accumulating in this area here, right here, with these elements on the roof. But none of it actually impacts the system to a point in which might actually have an effect in terms of the production. So we're very comfortable with our projections of 5.7 solar peak hours and 18.3 energy storage hours. Now, if I was to change this to the month of the year all the way to summer solstice, notice how now my shades change a little bit, but not so much. Just about 4 o'clock or so. I mean, same thing. It's just that there's not as much sun as there was during the summer. At 5 o'clock already, it's getting dark. The amount of irradiance during this time of the year is much lower. However, in the case of Puerto Rico, that actually does have it's not as detrimental as in other places in the world, because we don't have as much cloud cover during the winter. It's much more dry. Therefore, it's perhaps better time to generate electricity. So basically, that's in a nutshell, what design is. We have also taken into consideration the use of battery systems to cover for at least one air conditioning, lighting, and all your IP and IoT communication systems. That altogether, looks to be somewhere around 2,000 watts per hour average at 24 hours. That means that at some points of the day, we're going to use the air conditioner that air conditioner is going to be working under those, under the system, which is basically what we call a critical panel. We'll basically set aside a bunch of breakers, focus on the IT side, on the on maybe one or two air conditioners and some lighting elements, so that whenever there's a power outage, your IP and that section in which you have the air conditioner and those lights will continue to work. There's resiliency. We can actually have a lot of the lighting on the building run on the battery system and on the solar. And in the case of an emergency, the backup would actually allow for all that lighting and the AC and the IT and IP systems to work. Now that air conditioner has to be a small one, no more than 36,000, 36 BTU or so. We are looking into, our design calls for systems that are capable of handling tri-phase, incoming energy, so we can actually interconnect with PREPA, not for net metering though, simply just for the event that we might actually need PREPA for contingency, or also that the system can actually decide from where it's actually going to be drawing its energy at any time during the day or during the night. Okay. So this is the performance, which is basically how much energy you're going to be generating during the year. And peak time, you're looking at around 1.7 in April, same as June, 1.6 in July, 1.7 in August. This is actually based on simulation based on weather patterns, usually affecting the area, as well as heat. Heat is not particularly the best friend of solar energy, and actually may be detrimental. So that's why whenever it rains and then the sun comes out, there's a humongous spike in energy production on part of the solar arrays. So this is the system loss diagrams in terms of your DC, EC, and others. So everything looks to be up to par. The irradiance in the area is about 1.9, and we're looking at maybe just about 1.904, altogether. And incident angle modifier, if there's any incidents of cloud coverage and so on and so forth, our irradiance averages would actually be around 1.760, which is really, really good considering that the normal, the high average, it's about 1,800. So that's not bad, especially for San Juan, where it actually rains much more than in the south. All right, so that's in a nutshell, the design. I'll be directing you to another video in a short while that's actually going to explain the proposal itself. Hopefully we'll get to help you on this, guys, and feel free to give me a call and ask questions. And again, don't feel pressure in any way or form in terms of dealing with us. We will provide you, very likely, the most aggressive price in the market. But if you understand that there is a better option there for you guys out there, please feel free to use our proposal as reference. That's the best, least I could do for good friends. All right. Okay, guys. Talk to you in a bit.